Hi everyone, today in Integrated Math 2 we're going to go over Chapter 6, Lesson 3. Here are the objectives. Make sure you write them down in your notes. Alright, so let's go over Postulate 6.1, which is side, 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 also known as Sas Congruence. So if three sides of one triangle are congruent to three sides of a second triangle, then the triangles are congruent. So as you can see here, we have side AB, which is congruent to side ED. Then we have side BC is congruent to side EF. And the reason why I know this is by the number of marks they each have on the sides. Then I have AC, which is congruent to FD. Because I know all the sides are congruent, I can say that this triangle ABC is congruent with triangle DEF. And notice I'm very particular on the order as I'm going from 1 to 2 to 3. I go 1 to 2 to 3. Keep that in mind. So I'll put the little numbers here as a way to help you remind yourself that the order does matter for these as well. Then we have Postulate 6.2. Side, angle, side, also known as Sas Congruence. If two sides of the included angle of one triangle are congruent to two sides of the included angle of the second triangle, then the sides are congruent. So in this case, we have angle E here, which is congruent to angle B. And then what we also have is angle BC, which is congruent to FE. So let's say those are two. So notice what we have here is side, angle, side, side, angle, side, which is Sas congruence. So because of this, we know that triangle ABC is congruent with triangle DEF. So let's try example 3. Remember when we're doing two-column proofs, we have the left side as the statement side and the right side as the reason side. We know that these are equilateral. Then I'm also given the information that side JP is congruent to side MP. And these angles, JPK, is congruent with angles MPL. And then we want to prove that these two triangles here are congruent to each other. So first thing we want to do is to say our given. In this case, triangle KPL is equilateral. Easy enough. Then the second thing we can say is that PK, right here, is congruent to PL, this side. Well, the reason why we can say this is because we know we have an equilateral triangle, which is our reason for it, definition of equilateral triangle. Technically, we can even say that the KL side is also congruent, but that's not going to help us. So we're not going to go ahead and mark that. But it's good to know. Then we're going to go back to our given because we can't do anything else with the definition of the equilateral triangle. But what we can now say is that JP is congruent with MP, which we know because it is given. And then we should look again and we're like, oh, I have another given because I'm stuck from my third step to get to my fourth step. So let's go back to our givens. Well, they gave us another angle, angle JPK, which is congruent to angle MPL. And then we look and we're like, okay, have I actually proven that triangle JPK is congruent with triangle MPL? Well, as you see here, we have marked, we have a side, we have an angle, and we have a side. Side, angle, side on both. And they both are equivalent to each other. And remember, we have the property of side angle side to prove something is congruent. So then we can actually say that triangle JPK is congruent to triangle MPL. And this is because of the side angle side.